Hello and welcome to this third monitoring and maintenance lecture in this course, Master in Artificial Intelligence. So, in this lecture, we will talk about model drift detection. We talked about data drift detection in the last lecture, right? So, let's talk about model drift detection. So, the model drift detection requires you can look at monitor the model for drift or changes in the model behavior over a period of time, and there you need to compare the predictions on the ground truth labeled or expected outcomes and detect the discrepancies in the performance or degradations in the performance. So that's the way you can detect whether your model is drifting. And there are a few techniques that you can use, like concept drift detection, anomaly detection, and ensemble monitoring to identify the data drift. Let's take a look at each of these. So, question is how to use these techniques of concept drift detection, anomaly, etc. So this, can help really identify the model drift by monitoring changes in the model behavior. That's what we do in performance over a period of time. And how can you use each of these techniques? Let's take a look at that in a little more detail. So the concept drift detection basically requires is a Windows-based method. Windows, not the MS Windows. It divides the incoming data stream of data into fixed size window or sliding windows, and you monitor model behavior within each of these windows. You measure changes in the model performance metrics like accuracy, F1 score, etc. over time and detect significant deviations from the historical performance. So that's what is Windows-based method for concept drift detection. Also, you can use classified drift detection techniques in which you train multiple classifiers using historical data and periodically evaluate their performance on the new data, and you detect changes in the relative performance of the classifiers or emergence of new patterns or concepts in the data. Now, obviously, this can be used for the textual data or not textual data, but the classification kind of a data. Then there is a technique called residual analysis for anomaly detection, in which you calculate the residuals or prediction errors of the model on new data and monitor changes in their distribution over a period of time. An increase in the frequency or magnitude of outliers may indicate a model drift. So that's how you do anomaly detection. Then there is also an out of distribution detection. In this, you use techniques like density estimation or distance based methods to identify instances that are significantly different from the training data distribution, as you see here. So you have your training data distribution, and then in deployment, you look at an inference. There are two sets of data that are ticked right, and there's a third set of data that is not right. An increase in out of distribution samples suggests model drift or changes in data generating process also. We need to figure that out. But you see something is wrong. Then there is this ensemble monitoring model consistency, in which you train a set of model, an ensemble of model using different algorithms, right? And the hyperparameters and subsets of features, and monitor the prediction on new data, right? And then you measure the agreement or consensus among ensemble members, different members of your model, and detect discrepancies or inconsistencies that may indicate model drift. Then also in ensemble monitoring, you can do dynamic ensemble adjustment. You adjust the ensemble weight, the weights that you give to different models. Ensemble means there is a collection of models in your portfolio or for your program. So you adjust the ensemble weights or compositions based on model performance and model performance matrices or drift detection and detect drift signals, right? So, and then you incorporate mechanisms for adding or removing models from the ensemble basket that you have as needed to adapt to the changing conditions that you need. Right. Also, you need to be clear on what are the drift detection metrics. So you need to define the drift detection metrics or statistics based on your model predictions, residuals, or other relevant indicators. And monitor such metrics, that is like prediction accuracy, error rates, calibration, or confidence scores, and detect significant deviations from the expected values. So that's how you can use after having learned how to use the techniques, you use the metrics to figure out whether the model is drifting. And also there are two monitoring strategies that are adaptive. You can implement adaptive monitoring strategies which can adjust the detection threshold and sensitivity levels based on the contextual factors or historical data patterns. So you can use such techniques for as online learning, reinforced learning, or Bayesian inference to dynamically update monitoring parameters and adapt to evolving conditions. So you don't have to manually do it, but you can also automate the whole process. Establish feedback loops to collect ground truth labels, what is happening on in real life, or user feedback on model predictions. Then validate the model predictions. Use this data to validate model prediction. Identify not right, incorrect classifications or errors in the classification, and trigger corrective actions or model updates in response of the drift detection models. And that's how you set up the feedback loops. So by leveraging concept drift detection, anomaly detection, and ensemble monitoring and adaptive monitoring as strategies, you can effectively identify model drifts and take proactive measures to maintain model performance and reliability in dynamic and evolving environments as we keep coming across. So having looked at both the types of drift, we will now look at how to monitor and maintain the deployed data and what are the remaining steps that you need to do in the next lecture. So thank you so much for watching this third monitoring and maintenance lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions, and also download the PDF file to take a look at anything that I may have asked you during the lecture.